Welcome back to Huawei Routing and Switching Elite Training. Today topic we are going to discuss on STP spanning tree protocol. Let's start our part 4.
We are going to look into the next topic here, MSTP. Now MSTP is very popular in your exam as well as in your enterprise network. Okay, so first we are going to look into the basic concept of MSTP, why there is a need of MSTP. Then we are going to look into the MSTP packet format. How do we calculate MSTP and how do we interoperate between MSTP and RSTP? And finally we look into the fast convergence on the MSTP. Now one of the limitations of the RSTP and STP is this: all VLAN on a LAN use one spanning tree. Now this is a major drawback on STP or RSTP. Now if we look into this topology I have three VLAN, VLAN 1, VLAN 2 and VLAN 3. Now if you notice that I have one root over here. This is my root, S6 is my root. So being the root, the port will be in forwarding and I have two alternate port over here to prevent the loop. Now as you can see that if let's say PC3 on the left side here using a VLAN 2 want to go to PC2 on the other side here, it actually have to cross to here, go down and come here. And you notice that due to this we are actually wasting our bandwidth and we have to take a longer path for us to go into the destination. Hence we need to have another method for us to remove this limitation. That is where the MSTP come in. Now let's look into some of the basic concept on the MSTP. Now when you look into this topology, you'll notice that we have three regions: region 1, region 2 and region 3. Now how do we divide the region? Now you can see that the region have a region name. Okay, so before we start the MSTP, all the switches need to be MSTP enabled, and by default Huawei using MSTP, that's the default. Alright, so we need a name. Alright, so you can see that we have three different names here, so that actually tells us that we have three different regions. Now another thing that you have to configure when you configure MSTP is the revision level. So revision level is not a version number. The version number of MSTP is version 3, but revision number is actually part of the configuration that need to be matched for them to be in the same region. Now for example, if let's say I have these three switches, the default revision is 0, so you don't have to always start from 0. You can start from, let's say, 5. Alright, you can actually choose the number, but if you are going to choose a 5 for the revision number, each of these you are going to choose 5 for example, and each of the switch you have to configure the same name, which is region 1. Now on each of the region you also need to configure the VLAN to MSTI mapping. Now the MSTI here is an instance, so as you can see that here I have instance 2 which map to VLAN 2 and I have instance 4 that map to VLAN 4. Now you do not need to have one VLAN for one instance. So for example, I have instance 2 here, I have a VLAN. So in this example, our VLAN is VLAN 2. Now not necessarily have to be only VLAN 2. I can have VLAN 2 and 3 that map into instance 2, and I have instance 4 that map VLAN 4 and 5. For example, okay, so we can map multiple VLAN into an instance, but we only can map one VLAN to one instance. Okay, I repeat, you can map multiple VLAN into one instance, but you only can map one VLAN to one instance, so you are not allowed to map one VLAN to two instances like this. Right, so these are some of the basic things that you need to aware. Let's look into some of the terms related to MSTP. So here we have CST. Now CST stands for Common Spanning Tree. Now common spanning tree, I want you to think of like in region 1, you notice that I have 3 switches. And think of this switch inside a cloud. Okay, and they are all connected together. So it's between that region number 1 and region number 2. They are actually connected through this blue color line. Alright, so this is called CST. So here we have a blue color line. So here we have a CST. So think about like I have 3 region, 1, 2, and 3. This one is like a 3 big giant switch connected together. If you still remember on how we configure calculate the spanning tree protocol, so first we are going to select the root, right? Then we are going to look into the shortest path cost to the root, for example. All right, so as you can see from here, I have 3 region, and inside this 3 region, S1 is the root because it have a priority of 0, let's say. And let's say now the switch 7 have a priority of 4096, and switch 4 have a priority of 8192. So as you can see from here that they are going to do a comparison, and the highest priority here will become the CIST root. Now what it means by CIST then? CIST stands for Common and Internal Spanning Tree. So the common spanning tree and the internal spanning tree, you are the root. So here we have S1 because the priority is highest. So as you can see, because that you are the highest, the port that connecting region 1 to region 3, which is this particular port, and this particular port will become the designated port. And this port here and this port here, which is representing here and here, will become the root port. That is for our common spanning tree. So think about the common spanning tree just like your ordinary spanning tree. It's just that now you mask out all the detail inside your region. So here we have a common spanning tree, and we have a common and internal spanning tree, and the common and internal spanning tree root I just mentioned. Okay, now what is the IST then? Now if we zoom into the region 1, in region 1 we have 3 switches. In these 3 switches, we have 2 instances, which is MSTI2, instance 2, and MSTI4, which is instance 4. Now, for example, if let's say here, I have instance 2 and instance 4 with a VLAN mapping of 2 and 4. Now, if I'm going to create a new VLAN, let's say I'm going to create a VLAN 5. So this VLAN 5 will belong to which instance? Now, if you never do any configuration, by default, this VLAN 5 will go into instance 0, and that instance 0 will become your IST, okay, internal spanning tree. Okay, so here we already know what is the common spanning tree, internal spanning tree, which is a common and internal spanning tree. We also look into the root, and next we look into the master bridge. Now if we look into this diagram, let me draw it again. So I have 3 different regions that are connected together. As I mentioned, think of it like these are the 3 different big switches. Okay, so now I have a priority of 0 here. So I have a priority of 4096, and I have priority of 8192. Now since you are the root, so your root path cost is a 0, and the nearest to the root path cost would then be forwarding. So here we have our common spanning tree. This is a forwarding. And you also notice that between switch number 6 and switch number 8, which is this part here, you can see that here I am forwarding and this is a blocking, because that the priority here is higher than this priority on region 2. So here we are in blocking state. And the one that connecting to the root, this part here, which is the S7, this is my master bridge, and here also will become my master bridge. There you have it, all the terms related to MSTP. Now let's zoom into our region here, region 3. Now as you can see on the region 3, we have a switch of S7, 8, 9, and 10. And you also can see that we have the IST instance 0. As you can see that the configuration here on this region 3 is a mesh topology. You can see that all the connections are all connected. So for the internal spanning tree, you notice that this port is blocking, blocking, and blocking. So for the IST instance 0, our connectivity is fine. But what happened to our instance 2 and instance 4? So let's have a look here. So now we zoom into the region 3. Now, on this region 3, we have two instances, instance 2 and instance 4. If you still remember, the main objective of having the multiple spanning tree is to make sure that we have efficiency. So here, switch 9 is the root for MSTI 2. Now, since you are the root, you can see that here we have our forwarding port, whereas here we have our blocking port. Alright, and for the instance 4, switch 8 is the root. Okay, so for the MSTI number 4, I am the root. So this is forwarding state. Now if you look into overall, as you can see that all the link, so here this link is being used in instance 2, but this is not being used in instance 4. This is being used in instance 2, this is not being used by instance 4, and vice versa. As you can see, there's a pattern here. So by having multiple instances and position the root strategically, so you can see that we optimize the path. And as you can see that we also have our MSTI 0. The MSTI 0, as I mentioned, that this is the MSTI 0. So anything that is not mapped, you are the root. Okay, so since you are the root, the rest over here will be blocked. Alright, so here you have to remember we have our common spanning tree, which is connecting region to region. You can see that from here to here. So here I have a master bridge, and we also have our MSTI that map into our instance. So this is the root and this is the root. Now in MSTP we have two additional ports. Okay, so here we have the master port. Now the master port is the port that connecting to our root. This is our CIST, common and internal spanning tree root. So this is my master bridge, and this is the lowest cost toward to my root. So we call this as a master port. And whereas for the region to region, you can see there's a switch 8. This is called the H port. This is the H port because that it connect region. If you still remember our region here, we have region 1, region 3, and region 2. So our root is here. We have a root here. So here we have our master bridge. And on the master bridge, the port here, we call this as a master port. Now, between region 2 and region 3, this port, we call this as a regional H port. Alright, so this is the regional H port. Now, these are the two new port status when we configure multiple region in the MSTP. Now what you are seeing here is the BPDU field. Alright, so this is the packet format. Now what you can see from here, all the way from top to here, the white color, these are all the common RSTP. Okay, so whatever RSTP field have, the MSTP will have it. Now when we look into the MSTP, these are the additional field. And please remember that they do have a different format for RSTP. So the first format is .1x, which is the IEEE 802.1x, which is S here, and the other one is legacy. Alright, so we should actually use the standard and not the legacy. Now we have a way for us to change this. If let's say we can go back into our headers. Okay, now as you can see here, we can use this command called STP compliance. So for you to configure, you can actually use STP compliance using .1s, or if you want to use the legacy, you can just undo STP compliance. Alright, so undo STP compliance, basically you are using auto. Alright, auto. Now if you want to use legacy, you can just use STP compliance legacy. Alright, so here we have two MSTP format. Now, what more interesting here is you can see that once the BPDU have this MSTP, you notice that they have a version 3. So on the version 3, we have this MSTP specific identifier. So we have a format selector. This is a 0. If you still remember the name, the revision number, and whenever you are in region, let's say you are in a region 1, and let's say now you have a revision 1. Now these two combine and they are going to do a hash. Alright, the hash will be in the config digest. So the hashing also consists of the mapping. If you still remember MSTI, let's say 2 with a VLAN 2, instance number 4, we have a VLAN 4. Now this type of information together with the region and the version will become the hash. So when two of the hash, when they do compare during the BPDU exchange, they will know that whether this is generated by which region. And on top of that, we also have a MST configuration. This is on the instance. So we have the instance flag, the region root ID, alright, our instance internal root path calls, we have the bridge priority, we have a bridge port priority, and the remaining hop. So I'm not going to go through each and individual of this. You can refer back into the .1x standard for you to have more detailed information on all the field and for what purpose is those field for. Okay, so let's look into the MSTP calculation. So here we are going to look into the CIST and the MSTI. Alright, just to recap back on what is a CIST, if you still remember that we have 3 region 1, region 2, region 3, let's say. So these regions are connected in triangle. Alright, within the region I have multiple switches inside there. Okay, alright. Now in the CIST, we are going to look into who is the root for the CIST. So we are going to look into the IST instance 0. And assuming that here I have a priority of 0, and here I have a priority of 4096, and here I have a priority of 8192. So clearly I have a root over here. So then I'm going to calculate what is the root path calls, alright, to the root. So here we have the root switch device ID. Alright, so if let's say we have the similar MAC address, we are going to look into priority. So assuming that the priority is the lower number, basically means that you have a highest priority. So this region 1 will become the root. Alright, or we call this the CIST root. Then we are going to consider the external root path calls. Then we are going to look into the root ID, which is the regional root ID. So among the region, they are going to select one of them as a regional root ID. Then they are going to consider the internal root path calls. Then they are going to look into the device ID, designated port ID, and if let's say everything is the same, then only they look into the receiving port ID. Now this is a calculation on selecting who's the root for the CIST. So basically it's very similar to the ordinary RSTP selection. Now within the MSTI, or in the instance within the region, now you can see that they start to look into the root based on the regional root ID. Then they are going to look into the internal root path calls, designated switch device ID, port ID, and if everything the same, then only they look into the receiving port ID. So here, these are the order on how the STP or MSTP selecting the regional root as well as the CIST. So compare to the root, device ID. Alright, then if let's say it's the same, then compare the external root path calls. If still the same, they compare the regional root ID. If still the same, compare the internal root path calls. And if still the same, they look into the ID of the designated switch. Then they are going to look into the port ID. And if everything is the same, then only they look into the receiving port. So here you have the principle on how you can do or to derive who is the root for the CIST and who is the root for the MSTI. So we are going to look into some of the example over here on the next slide.
Thanks for watching. Please do not forget to subscribe to our channel.